All right, chapter 3, this is where this class really gets going. We're going to take a little break from limits and just work on derivatives. Today we're going to do a rule that you're going to be using over and over and over again. And the good news is it's pretty easy to do. To take the derivative of x raised to a power. And this n right here could be any number. It can be positive, negative, fractions, decimals. It always works, as long as that's a number. And it goes like this. You take that n, bring it down in front and multiply, and then subtract 1 from the exponent. That's it. That's the power rule. Simple, but powerful. Now let's do a few examples. So for example, number 1, suppose that the function is x cubed plus x to the minus 4 plus 7x plus a 9. So basically this is just 4 small problems all in one function. So you take the derivative of each one at a time. So you take the exponent 3, you bring it in front and multiply, and then subtract 1 from the exponent. So that's going to leave 3x squared. And then for this one, take the negative 4, bring it in front and multiply, and then subtract 1 from the exponent. So that one's going to be minus 4x to the minus 5. Now for this one right here, its exponent is actually a 1. So you take the 1, bring it in front and multiply, and then subtract 1. So that's going to be a 7, and then x to the 0 is 1. So it's really 1 times 7 times 1, or in other words, just 7. And the derivative of constants will always be 0. There's two ways to look at that. One is using the power rule. So right now, the number 9, I could rewrite it as 9 times 1. And then for 1, I could use x to the 0. Now do the power rule. So that means that the 0 goes in front and you multiply, and then subtract 1 from the exponent. So we get 0 times 9, so it's 0. Another way to look at it is, if it was just the function y equals 9, that is a horizontal line where y equals 9. And the derivative tells you the slope. The slope of this line is 0. So the derivative of 9 is 0. Now one last thing is, I don't really like negative exponents, so I'm going to rewrite this one. So the derivative is equal to 3x squared minus 4 over x to the 5 plus 7. That looks much better to me. Then, for example number 2, how about if it's y equals the square root of x? So I'm going to keep it simple and just do the square root of x, because this is a function we take the derivative of over and over again. And you could go through these 4 steps, or at the end you could just remember the derivative of the square root of x is 1 over 2 times the square root of x. Well, why is that? Good question. So first, you could rewrite the square root as a 1/2 exponent. Then do the power rule, so that 1/2 goes in front and you multiply, and then subtract 1 from the exponent. So then y prime, or the derivative, will be 1/2 x to the, this is going to be a half minus 1, so that's negative 1/2. And as I may have mentioned before, I don't really like negative exponents, so I'm going to rewrite this as 1 over 2, and then x to the 1/2. And then finally, I could finish by saying that that is 1 over 2 and the square root of x. So 1, 2, 3, 4 steps. Or you could just remember the derivative of the square root function is equal to 1 over 2 times the square root function. That little shortcut right there can save you a lot of time. Okay, then on to some more examples. Example number 3. Suppose that you have a polynomial. Y is equal to negative 2x squared plus 5x plus 8. So we're not only going to take the derivative, but we're going to find out where it equals 0. So first of all, the derivative. So you take this exponent of 2, bring it down in front, that's going to be negative 4, and then subtract 1 from the exponent. So when you subtract 1, it will leave x to the 1, which you could just write as x. The derivative of 5x. So this one's exponent is a 1. You take the 1, bring it down, and multiply. It gives you 5. And when you subtract 1 from the exponent right here, it's going to leave x to the 0, which means multiply by 1. So take this 5 and multiply by 1. Yet another way to look at that is if you just had the function y equals 5x, that would be a line that looks like this. And the derivative will tell you slope. Well, as you may remember from Algebra 1, the number sitting in front is the slope. That means the derivative equals 5. And for a constant, the derivative is 0. So that means we're already done. Now set it equal to 0. And solve for x. So I think I'll add 4x to both sides. And then divide both sides by 4. So the derivative equals 0 when x is equal to 5/4. Or in other words, that would be 1 1/4 or 1.25. The only reason I'm putting the decimal right now is because I'm going to use the calculator to verify, and I know that the calculator will give me a decimal answer. So first of all, graph the original function. And then zoom standard, and it should look like an upside down parabola. So it does, but I can't quite see the top. It went actually past 10. So I'm going to change the window, and for the y values, have it go up to 15. And then we should be able to see the whole thing. Then what's happening right here when x equals 5/4? Trace and plug in 5 divided by 4, or 1.25, and that is the vertex of the parabola. So the parabola looks about like this, and when it gets to the top of it, which is also called the vertex, or it's also called the maximum point, then that's when x is 1.25 and y is 11.125. So that is a very important application of derivatives. They can tell you where there's maximums, and also if there was a minimum, it could find that as well. So if you're riding this roller coaster and you want to know when are we going to get to the top, that's the point that's at the top. Then for example number 4, when is the derivative undefined? And in this one, the function is going to be the 5th root of x minus 1. So in order to be able to use the power rule on this, I need to first of all rewrite it as x minus 1, and then 5th root can also be represented as a 1/5 exponent. And then the power rule. So take this 1/5, bring it down in front and multiply, and then subtract 1. So that'll be 1/5, and then x minus 1. 1/5 minus 1 is negative 4/5. And so now I need to rewrite this so that it doesn't have a negative exponent. So it's going to be y prime equals 1 over 5 and x minus 1 to the 4/5. And then the question is saying, when is this undefined? Well, one thing that will definitely make things undefined is when the bottom equals 0. So you can set the denominator equal to 0. And then perhaps you could just look at that and see when x is a 1, that's when it's going to make it equal to 0. Or you could divide both sides by 5 and it would still equal 0. You could then raise both sides to the 5/4 power in order to get rid of the 4/5. And the right side would still equal 0. Add 1. And it's undefined when x equals 1. So what's happening to the graph there? So the original function was the 5th root. So for that, I'll need to go to math and then use this one that says x root. Then I can type in the 5th root of x minus 1. And then zoom standard. And as you can see right there, at x equals 1, the graph went vertical for a moment. That's why the derivative does not exist. Okay, there's another one that we need to do, or actually two more. So this is another one, like with the square root, that you're going to be using a lot. And you could go through these steps, or you could just remember. When you have 1 over x. So the derivative of 1 over x is equal to negative 1 over x squared. So remembering this fact will save you a lot of time in the future. The reason for it, the reason for this being the answer is, in order to use the power rule, you need to rewrite this one as x to the negative 1. And then do the power rule. So this negative 1, you bring it in front and multiply, and then subtract 1 from the exponent. So then y prime is equal to negative 1 x to the negative 2. And you're right, let's not leave that negative exponent there. So the final answer is negative 1 over x squared. So every time you run across 1 over x, you could go through these steps, or it'd be faster and better to just remember the derivative of 1 over x is negative 1 over x squared. And the last one is just a little graph. Suppose that you don't know what the function is, but you know what it looks like. And it looks like this. So it goes like this, a straight line, and then part of a circle, and then it curves up like this, like it's gonna make another circle. So it looks like this. And then the questions are part A. So this whole thing is f of x. When is the derivative equal to 0? So the derivative equals 0 means slope equals 0. So for this whole straight line right here, this is a horizontal line, so its slope is 0. So the answer in part would be from 2 on, this is going on forever. So from 2 to infinity, the derivative equals 0. And I need to put a round parenthesis right here because I cannot include the 2 because it's not even continuous right here. So at x equals 2, the derivative does not exist. Now there's another place where the derivative equals 0, and that's right here at the top of this hill. Sort of like when we did the parabola and found out the derivative equals 0 at the maximum. So right here, the tangent line would look like this. That's horizontal, so the slope is 0. So also x equals 0. And then for the last part, when is the derivative undefined? So when the function is not continuous, the derivative does not exist. That means x equals 2, that's going to be one of the answers. Also, if there's a cusp or a sharp point, the derivative does not exist. So at x equals 1 and also x equals -1, the derivative does not exist. And that's it for section 3.1.